Hey, QED Coders, this is Michael, and we have a guest on Discord, Zora. Welcome, Zora. Um, Today, I am planning a discussion on the different specification methods in Janaga.net. But Zora has been posting on Discord some really interesting thoughts about the attestation of immutable data and how that relates to policy. So we may have a discussion on that as well. So welcome everybody. If you would like to join us on Discord, we stream here every Thursday at 1400 UTC, I believe it is. And you can get the link to join Discord and join us on the stream on immutablearchitecture.com. All right, so I'm Michael Perry. I am working on right now the second edition of The Art of Immutable Architecture, and so far got the first draft of all the chapters done, working through the technical reviews. Sandra Mack, my technical editor, also a tech reviewer on I think I have it here. On a distributed systems book that you probably already have on your shelf. I think I brought it downstairs so that I could read it on my easy chair. But why do I have Lex Friedman's name in my head now? Oh, goodness. Designing large-scale distributed systems. So he's a veteran in this space, so I'm very happy to see his feedback, how he's receiving the book as he's reading through it. So today, I would like to talk a bit about how Janaga.net exposes different ways to use specifications within your applications. And so let me switch right away to the share. All right. Martin Klipman, sorry. Not Lex Friedman, Martin Klipman. Anyway. Okay, so we have... we need to show this on the stream. There we go. We have several different ways in a Janaga.net application to use specifications. This is the blog Maui application that you can find the source code to on GitHub in the Janaga organization. And this is a working example that I am using to practice, to exercise, to demonstrate several different patterns of building a Janaga application for Maui. The idea behind this is that there will be also a blog React that shows the same model, now hitting it with React, showing those two things working together. And then there will be a blog Blazor and a blog React Native and whatever else comes our way. Those are the four platforms that I am currently targeting. But if you're a fan of Vue, if you're a fan of Angular, if you're a fan of Kotlin, Swift, whatever you like, please reach out to me and let's work on making sure that Janaga works well with your platform. A specification, just to remind us, a specification is a way to query a model. So this specification right here, given a user as a starting point, I want to match, I want to match against that user. And so I want to find sites. So those are facts of type site. Waiting for my mouse to come back. I think that I need to change the battery. There we go. So facts of type site, and now I'm filtering those. So first of all, I only want the ones that were created by this user. So as a reminder, in any specification, whenever you introduce a new unknown, a new label into the specification, you have to relate that to the previous labels. So in this case, user is the only previous label. And then I further want to filter those where there is no deleted fact, such that there is no restored for those deleted facts. So if it's been deleted but not restored, then exclude it. That's the idea there. So now you've got those sites that have not been deleted. Now what do? You project. You find, you grab objects that have a site property, that is that actual fact, and you've got the names and the domains, and these are both observable. So we'll get back to when you use observable and when you don't, because that relates very heavily to the different specification methods. So now how do you produce this observable collection of names? Well, you do another specification. So we're labeling the site names, relating them back to the site, and we are looking just for those that do not have a next. There is no next site name whose prior collection contains this one. So it hasn't been superseded. Now, we've got those names. Here we are selecting the values, so that's an observable collection of strings. And then here we have the domains, so an observable collection of strings for site domains. And that gives us back a specification using this anonymous type right here. So we've got a site, we've got an observable collection of strings for names, and an observable collection of strings for domains. Because it's an anonymous type, I have to immediately use it. That type is just defined in this scope, and I can't give it a name. It's anonymous. So I immediately use it right here to do JNuggClient.watch. Let's go ahead and make sure that we start up the simulator so that we can show this. What JNuggClient.watch will do is, given this specification and this starting point, the particular user who's logged on, give me back the projections. But now, watch doesn't give you back the projections as a response, the way that, for example, query would, but instead it calls you back with each of the projections. The reason being that it continues to observe. As new projections meet those specifications, they will call you back with those projections as well. And then right here at the end of that callback, you return a method that it will call whenever that projection no longer meets that specification. So in this case, we're adding a view model to our sites list here, and we're removing that view model here. So when would a projection no longer meet those specifications? Well, right here, if you were to delete the site, it would no longer meet the specifications. So the simulator has started up. Let's see if it's going to deploy. Yeah, it's still working on the deployment. So we set up a specification, we use that specification. We've got several different ways of using specifications. So those ways are control space. Those ways are query, query local, subscribe, and watch. Let's make a little query local. I'll put watch first and then subscribe. All right, so those are the 4 methods. All right, thumbnail bait right here. Okay, so what are these 4 methods? Well, these 2 return results immediately. Oh, wow, okay. This was from MATLAB. Great. All right, so those 2 return results immediately from a, we'll say a specification. And these 2 start an observer. Yes, those 2, but it's these 2. So, query and query local will just return those results and stop. I'll take out the word immediately because it's really asynchronous. In the async await way. This is also kind of asynchronous, but not in the async await way. This is asynchronous in that it's going to continue to feed those back to you as they come in. So in this case, we used Janaga client watch, and so we get back our projections, and we add them to the observable collection. So they show up in the view. Okay, and then also we can see the title and the domain showing up there, because whenever we receive a brand new domain or a brand new name added to that observable collection of strings, we'll call back right here and pass that string in and set the name property of the header view model. Or here, set the URL property to the domain. So that's how those are getting populated. So it's all through callbacks, which means that if I were to change something, this callback would immediately get hit. For example, let's go in here. This one, we change the name to edited in Polyglot. I'm going to hit the edit button, and I'm going to edit in Android. Okay, so that means that it hit my callback and set the view model name property to edited in Android. Very good. So that's what watch does. It keeps that that observer open. It loads things from the local store, and then also looks for any changes that the user might make elsewhere in the application. Now, if we learn something from the remote replicator, it will respond to that as well. Like if something else loads some new data, it will respond to that as well. But what if we explicitly want to set up keep alive, a live connection to the replicator? For that, we can change watch to subscribe. And so now with this, let's go ahead and restart the application, because I don't think this survives a hot reload. It would be nice if it did, but we still have work to do there. Let's see, used by another process. Well, maybe the other process was in the middle of restarting. Oh yes, build does build everything. Okay. So, yeah, subscribe is really is really intended for those scenarios where you need to know if somebody else is actively making changes to the model right now. So if somebody is actively adding new sites or changing the names or domains of the existing sites, it will subscribe to those. It will keep that connection alive, and it will update the user interface. Okay, it is ready. It is it is giving me trouble. Okay, let's switch tacks here and see if we can start this from here. No, everything's gone wrong. Okay. All right. No, I don't want to update those tools. I want my Maui app to work. Okay. Maui. Okay, I don't have the Maui tools installed there. Interesting. Okay, so what I'm going to do is I'm going to restart Visual Studio. And we will call that methods. Save that. Okay. Hold, please, while we restart Visual Studio. So we have switched from watch. Okay, that's the post list view model that we're looking at there. In the site view model, we have switched from site edit view model, site list view model. We have switched from watch to subscribe. Either one gives us back an observer. So what can I do with an observer? Well, I can, let me make sure that we restart Visual Studio. Here you go. We can monitor it. So I've got this nice little monitor method. And then we can also call stop. So stop means both, stop calling my callback whenever something new happens, which is the only thing that stop does for watch. But for subscribe, it also closes that connection to the replicator. Now, monitor, it's going to look at a couple of different tasks. Cached is a task boolean that tells you whether it was able to load this information from the cache, and loaded is it is resolved whenever you have completed the first fetch. So the idea here is that if you are able to load things from the cache, then okay, great. You're showing the user that you've done that. So while monitor is awaiting, the loading flag is true. Loading gets set up here, which I should probably, for balance, move it down in here. Set the loading flag only when you start monitoring. Up till this point, it's synchronous, so that would not be a problem. So, so the loading flag tells them, it's immediately loaded if it was in the cache, but if it's not in the cache, then the loading flag tells them that it is talking to the replicator. Okay. So now if it, not in the cache, then we do that. Here, by the way, we're also calling push. So that is also a task returning method, and that checks the queue. If there's anything in there, then it contacts the replicator and it tries to push those facts up. So the idea being, anytime you are starting a brand new observer anyway, go ahead and upload things from the replicator. So if you're going to talk to the replicator, just talk to the replicator. Yeah, you don't want my feedback right now. Okay, let's try this again. Is it going to work this time? Okay. So far, so good. So this is that we've changed things to subscribe. So while that's loading up, let me show you what the graph looks like right now. So I'll close the others. And in here, we have a, this is, I know you're working. I'm very proud of you. This is a set of specifications that give us the sites for a user and the names and domains for those sites. And when we run it against the replicator that that this mobile application is also using, then we get back these two sites. They were created at different times, and they have different domains. So here's the domain for QED code, and here's the domain for michaelperry.net. And they also have different trees representing all of the name changes that have occurred for these particular sites. So here I was demonstrating that we created a conflict and then that we resolved that conflict. Or I should say concurrent edit, because this is conflict free. It's not truly a conflict if everybody knows that both of these things are possible candidates. And then here is a very linear chain. Here we've got a concurrent edit, and then we bring it back together. And when we are all done with this, we should have just one name edited in, well, right now it says polyglot, but we just changed it. So let's see that change. I'll run it. And it updates the graph, and now we can see edited in Android was the most recent one. Fantastic. Okay, so now this has switched to subscribe. So that means that if I were to make a change here, we would see that change there. Let's add some code. And I want to create a new site. So this is going to be immutablearchitecture.com. So I want to await Jnaga client.fact new site. And so the creator is the user. Earlier on we did a login, and that gave us back the user. And then created at is datetime.now or UTC now. It actually doesn't matter because it converts to UTC anyway, but we'll be explicit about that. So now I want to set the name and the domain. So I will say await Jnaga client fact new site name. And so I'm going to have a name for this site, and the value is going to be immutablearchitecture.com, and the prior names is the empty set. Okay, so then I also want to set the, oh, that's I said name, I meant domain. Yeah, so that's what I want for the domain. And then for the name, site name, this is going to be the art of immutable architecture. There we go. And this also is going to be initialized with the empty set. Oh, yeah, I got that wrong. The empty set is a predecessor for site domain. It's the list of prior domains. This is the first one. Prior list is empty. Okay, so now when I call JnagaClient.fact, this is going to save that fact locally. It's also going to push that up to the replicator. And now the replicator knows that this application has subscribed to that site. So it should be listening. I did just see something happen over here. Interesting. Let's bring up the call stack. It's trying to do it's trying to do something about the timer. Okay, so there's something with the timer that it's using in order to refresh that that socket. So let's restart this application so that we can actually see this demonstration work, and then I'll go back and use this video to fix that error. That's what you can expect on this live stream. We find our errors and then we fix them next week. Okay, so now it has set up that socket. It hasn't hit the timer yet, so we're good for 4 minutes. And we run. Boom! The Art of Immutable Architecture shows up in the list. So we have set up a subscription. We have seen the facts come in from another device, and that was done in real time. So that, if I go back to, where's my list? Show me my list of methods. There we go. Yeah. So That is the difference between watch and subscribe. They both start an observer from a specification, but subscribe also sets up that live connection to the replicator. Now we have query and query local. What are these all about? Well, let me show you a place where I use query inside of the application. Well, first of all, I'll show you where I use query inside of Polyglot notebooks, and that's all over the place. So what does query do? Query hits the replicator first, grabs the facts that match that specification and pulls them into local storage, and then it runs the query using local storage second. So that way it's able to run the projections locally. It's able to merge that with all the information that it already has. But it's showing you the information that, the latest information that it's able to get from the replicator. So what if you're offline? Query will throw an exception because it's going to hit the replicator first, and then it's going to check locally. What if you have a slow connection? Query is going to be slow because it hits the replicator first. So there are some cases where that's what you want. You want to, you assume that you are online at this point and you want to get the most recent information. For example, when you log on. So let's talk about the app shell view model. And in here, we've got a method that lets us handle login. So we're going to use the authentication service to log in. That is going to do some interesting things. So let's go into the authentication service. And that is going to talk to the authentication provider and log in. So that sets up your token. But now you need to see who is the actual user now that I've got that authentication token. So here we don't yet have a user, but we have just logged in, so we've just gotten a token from the authentication provider. So what we're going to do is call janagaclient.login, and that is going to return both a user fact and a user profile. The user profile tells us what the identity provider thinks that user's name is. Now, when we have a user fact, we can also store that user's name as a successor to the user fact. And it crashed. 4 minutes has elapsed. I'll check the time code and make sure that's exactly 4 minutes, which will confirm my suspicion. Debugging on video, I kind of like this. I should do this for work. So what we want to do is, first of all, save the user in local storage so that I can get back to that user fact after you've restarted your application if you're offline. That's the purpose for that. But then here, we're going to update the username. So I actually have the user fact now, and I'm going to update the user's name. And that's a little function that I pass into the authentication service. So where is my update user name function? That's inside of Janaka config. Got this little function right here called update username. So given this user fact and this user profile, let's update their name. Now I just logged in, so I fully expect that the device is still connected, and it could make a connection to the replicator. So I do a query in order to ask the replicator to give me back the most up-to-date facts related to this specification, everything that matches the specification. So given a user, the one that just logged in, give me all of the user names such that the username has not been superseded. Here's that next prior mutable property pattern again. So this gives me back all of the leaf nodes of that particular tree, that graph. We just want to see the ones at the bottom. So these are all the usernames that don't have a next. And then we get back not the string, but this time we get back the actual username fact. So run that query, that stores it locally, and then it gives us back the results. Now, since I have used this pattern here, I could get back multiple usernames. So if their name changed from one device to another concurrently, we will end up with 2 leaves of that particular graph. So if the count of usernames is not equal to 1, then it could be 0. It could be that we don't have their username yet, or it could be that we've had a concurrent edit. So we should resolve that conflict. So if the usernames collection count is not 1, or, so now the or will only take place if the username count is 1, so therefore we can use single. We can say, yes, that single username, its value, if it's different from the profile display name, what the identity provider thinks the user's name is, then I want to update it. I want to create a brand new username fact. So I will create a username for that particular display name. And what is the prior? It is this collection of usernames, just the leaves, so that we can create one more layer in that graph and point up to the things that we're replacing. If the count was greater than 1, then that means that we are bringing those all back together. If the count is equal to 1, we're just creating a chain. If the count is 0, this is the first one, and that's the empty collection. So that works in all those cases. So the reason that we're using query here is that we believe that we're connected. We want the most recent information. And so if we can't connect to the server, to the replicator, and it throws an exception, we'll go ahead and handle that exception, and that will be a problem logging the user in, basically, because that's the process that we are in the middle of when we update username. So that's one of the places where query would appear in an actual application. Now there are other times where you don't want to hit the replicator because you don't want to risk the exception, you don't want to suffer the latency, and you don't need the most recent information. In fact, getting more recent information might actually be a detriment in some cases. For example, we are looking at a post list. So it has crashed. Let me go ahead and start it back up again here without the debugger and show you what we mean by the post list. So group, we are looking at the particular site. We see the list of posts. This also has a little edit button where I can go and edit the name and the domain. So this is the handle edit method that is assigned to that particular command. So you hit the edit button, it comes in here. So at this point, I need to get from the local storage the actual site name facts that are the most recent. Up till now, I've just been displaying strings, so I only projected name.value. But this time, I need the actual names. So here, I need just a collection of those names. I'm not going to set up an observer to keep watching for them as they change. I need a snapshot. And here, same thing with domains. I'm not going to set up an observer. I'm going to query to get a snapshot. I'm only doing query local so that this button is nice and fast. Bloop. Without the query local, that button has a noticeable delay because, oh, phone needs to make that connection to the replicator, run that specification. Nope, nothing new. Okay, let's run the query locally, and then show the modal. Now, we also chose query local because of the use case. What is it that you're actually trying to do here? You do have an observer looking at edited in Android, looking at the site name. Let me show you that observer. So here's the post list view model that has the edit button. It also has right here where we apply query attribute, so we get the site that we are actually looking for, and then we get the names of that site. Here we are getting named at value, and here we are setting up an observer. Oh, interesting. I'm not capturing that observer. Yeah, this one is capturing an observer, but that one's not. Aha, that's a leak. That means as I navigate away from this this page, that's still going to be observing. That's a problem. I don't think that's the crash that we saw, but that will eventually cause a crash, so let's fix it. So I set up an observer here, and every time I learn about a new site name, I set the title. So all I have is a string. I have discarded the actual facts, the site name facts, because I only projected this value, and I have discarded all the other candidates, because when I learn about a new projection, I just overwrite that title. So that means this is not enough information for me to eventually do, oh yeah, this is just navigating to it, for me to eventually update the title. Well, let's go ahead and update the title. So we've got the site edit view model. So we go in here, and then when we handle save, look at there's that that pattern that we've seen before. If the count is anything but 1, or the value is different from what the user just typed in, then record a new fact. But if the count is 1 and the value hasn't changed, no new fact for the name and for the domain. So this names collection here is the one that we initialized the view model with. So we create this immutable list of site names and this immutable list of domain names. And we capture that when we create the view model. We capture that when we navigate into the view model. So not here. Here we set up an observer. Here we just captured the results of that specification, and those are fixed. The reason for this is that if somebody were to make an edit to the name right now, we don't want the user to have to see that change on the fly. They're inside of a dialog box. But then, if they make a change and somebody else has made a change while they were in the dialog box, we want to record that as a concurrent edit. So the choice to use query local is deliberate, not just for low latency, not just for avoiding exceptions, not just for saving the battery so we're not making another connection to the replicator. It is for correctness as well, so that we only compare the states. We only capture concurrent edits if somebody is actually inside of the modal. So that is the use case for query local. So that gives us these four specification methods, and I think that covers the use cases. But this is why I'm building an application to really test that assumption. this doesn't create, in my mind, a nice, solid mathematical model that says, yes, this is all the use cases. It's nice and balanced. There's two that do the results asynchronously and just return them, and there are two that set up observers. But I think that might be an accident. I don't know that that's actually true. So it would be interesting to analyze these from the perspective of, go to the replicator first, use local. Local first versus local only. Query local is local only. Should there be a local first option? For query, that doesn't much make sense. Maybe, yeah, so let's make up a use case. Maybe we want to try to hit the replicator, and if we fail, then return local results, and do that in the asynchronous fashion. The problem I see there, and that's actually you'll see an issue in Janaga.net on GitHub, where I was thinking that that's what I wanted query to do, actually, and I actually even implemented something that did that, and then said, you know what, that's not quite right. The thing is, as an application developer, I can't really give you a good, solid definition of what it means to be online, what it means to fail. If it just calls the replicator and it hangs, is that a failure? Do you set a timeout? What's the value of that timeout? What kind of latency will the user tolerate in that case? Is there another way to achieve that result? And is that perhaps even a use case where you should set up an observer anyway? So in the end, I decided not to change the behavior of query. If we want to do a query that hits the replicator and then fails back to local, then we will give it a new name. But I am currently of the opinion that the application developer should switch to an observer, or they should call query and query local in the appropriate try-catch with a continuation or a cancellation token set to a timer, all that stuff, in order to specify the behavior that they want. So we will see where that lands. Then as far as setting up an observer, both of these do local first. So if you are subscribing to the offline first style of building applications, which is a good default, then these will behave the way that you expect them to behave. But if you need to actually get those results and stop your observer, there are ways that you can do that, but it's kind of clunky. In those use cases, you would want to switch to the asynchronous one. And then you want to be a bit more explicit. So the only difference between these is whether it holds open that keep alive. So that feels like a complete set to me, but this is one thing that I cannot even write the specification for, let alone prove. So that will be what I ask of you. So, dear viewer, dear QED coder, if you could please give Janaga a try. So if you're on .NET, Janaga.net is where I'm currently focusing all of my attention. But if you're a TypeScript or JavaScript developer, check out Janaga.js. That's where I was focusing my attention up until just recently. So it's still fresh. Where I'm there, it's working very well for React, and I need to make it work well for React Native. So create all of those use cases in React Native that I'm doing right now in Maui. So please give it a try. open issues on Janaga.net or Janaga.js. Both are on GitHub under the Janaga organization. And join the Discord. Come stream with us every Thursday. And if you are building an application, doing any kind of research, let's get in the conversation. So more people in there, I'll come back more frequently. Right now, I look at it about once a week. But yeah, so hopefully we will build up a nice community around this. We will have solutions. We will have advice. We'll help each other to create better software. And so, with that, I will see you next week. Thank you very much.